So now we're going to do our antibiotic resistance activity. So what you're going to need for this is some balloons. So in this activity, we use round balloons and long balloons. You're also going to need some thick tape, such as electrical tape. So we've got some red and blue here. Also some marker pens if you're feeling adventurous, and some pins. Now each of these components represents a different thing. So as I said, this activity is going to explain antibiotic resistance. And to do that, our balloons are going to be our bacteria, our pins are going to be our antibiotics, and our tape are going to be the resistant genes. So here we go. So first of all, you want the students or the pupils or the public to understand that antibiotic resistance is specific to bacteria. So we have different balloons to account for different bacteria. So you can use round balloons to represent cocci, i.e. MRSA or Enterococcus, or you can use long balloons to represent rods, such as E. coli or C. diff. So what we do here is we explain that antibiotics are special medicines used to kill bacteria infections or treat bacteria infections. And we do this by simply taking our bacteria, oh no, that doesn't have a resistant gene, our nice susceptible bacteria, and here's our antibiotic. So when you have a bacteria infection, you take antibiotics, and what does it do? Treats your bacteria by killing them. So then we talk about antibiotic resistance. Now we know that antibiotic resistance is caused by bacteria evolving resistance towards our currently used antibiotic drugs. So what is the result of that? Basically it means that these same bacteria have special genes or special superpowers that means that antibiotics can't kill them anymore. So then we have, and as you can see here, resistant to killing. Now what we will say is it's good to really double wrap your gene, which we haven't done this time, as you can hear the slight killing here. And one kind of thing is don't use masking tape or sellotape. It's really good to use really thick tape. And try get it on the thickest part of the balloon. So that's our kind of metaphor for describing what resistance is. In this activity as well, we like to talk about how resistant genes can be shared. So you'll notice in the last bacteria we had a red resistant gene, and we show here in a completely different species that it can be shared and also transferred. So here we have our resistant E. coli, our non-resistant E. coli. And a kind of another thing to do here as well is really personify the activity. So what we've done here is we've allowed the student, i.e. me, to design the bacteria, design their own E. coli, and also give the resistant gene a name. I think this activity is also really good for kind of showcasing the fact that resistant genes are really different. I think it can be a myth that it's always kind of one type of gene or one type of sort of superpower that they have. So you can allow the student or the kids to design their own. So here we've got a blue one, we have a red one, and I've actually named this gene Evil X. So really kind of inspire the kids with this. Another thing we have as well is, although a bacteria can't be killed by the red antibiotic if it has the red antibiotic resistant gene, how about a different kind of antibiotic, such as this blue one? Dead.